people to sell better, sell more effectively. We are an enterprise solution. We sell into the 1.4 trillion U.S. market that people spend on their sales budgets and sales teams within business selling context. We apply a lot of data science, machine learning. So from a recruiting pitch, we are hiring. We're looking for people with expertise in big data, Hadoop, large data clusters, applying Scala to solving interesting problems, translating your algorithms in machine learning from, let's say, MATLAB or R, or for some prototypes with SAS, things like that, into the big data context of enterprise sales. We're looking for back-end engineers, front-end engineers, UI, anything and everything that is involved in building a great business application. So if you're interested, I have these flyers out in front. Please grab one as you exit and consider Clari as a next place where you develop your careers. I guess, Vlad, if you have any additional announcements or any other people have recruiting announcements, this will be a great time to grab the floor and describe what your company does and why it would be a great place for future employees to join. Okay, we have Jeff here.
Sure, I have one recruiting announcement. I'm here representing Inside Vault, which is a company developing a advanced SCM marketing platform. We were actually one of the first to deploy code on Scala. All of our backend has been in Scala for almost 3 years. Brian Watson is another one of our architects, lead developers here. You can talk to either of us about the opportunities. We're located over in Redwood Shores, and the company has been expanding and growing quite a bit. Thank you.
Thanks, Jeff. Anyone else for recruiting announcements? We have Dan out in the back.
Yeah, I'm Dan. I'm not recruiting. I'm actually teaching a class on Sunday.
Yeah. Make it audible for everybody.
Hello, I'm Dan. I'm teaching a class on Sunday at Hacker Dojo. I invite everyone. This Sunday we will be wrestling with Scala. Before we had been teaching Python. This Sunday will be the first Sunday where we're teaching Scala, and we have an interesting problem that we're wrestling with. We're predicting the stock market. So I invite you.
What time is it?
At 1 o'clock, Sunday, Hacker Dojo.
Thanks, Dan. Anyone else for announcements? Going once, going twice. That's it. Recruiting announcements done. So next part of the agenda is the main speaker for today. I am honored and privileged to introduce the speaker for today, Dr. Lei Tang, who is heading the data science at Clari. Dr. Tang previously was at Walmart Labs, processing millions and millions of purchases through online Walmart.com, where he really made significant improvements in the product click-through rates on the email campaigns and demand gen on market demand gen. Now he's at Clari, transforming the way selling happens in enterprises. Again, by using data science, machine learning, Dr. Tang has brought in a new way of looking at the whole process of selling. He's going to touch on a few of the elements of machine learning and data science and how Scala is used to implement these algorithms. So without much further ado, please welcome Dr. Tang. So here's what I'm going to help you with. Yes.
Hello? Okay, working? Okay, thanks Venkat for the introduction. So you see, this talk about predictive analytics for sales. So actually, Clari is doing a very challenging job because you know what salespeople do, and we are selling product to salespeople. That's kind of one of the most challenging tasks. Okay, so I'm leading the data science efforts here. So right now in the Silicon Valley, Right now in the Silicon Valley, data is everywhere across different domains, not just sales, like marketing and sports. They're also using analytics to do this analysis, like agriculture, so almost any domain. When everybody heard about this big data science, most people would be nicely think about this. So like once you have data, you can figure out a certain way to convert the data into some value. That becomes your goal. And like if you have data, you have the value. But in reality, that's what most enterprise or most companies look like when dealing with their data. So data is stored somewhere in a hidden corner, which is bad. Like nobody knows going on. Nobody knows exactly what is going on there, but it's just there. Probably with a lot of data corruption, some workflow issues, but it's just dumped there. It's a dump. It's not a value. So that's why analytics come into play. So what analytics trying to do is basically trying to mine this data, trying to mine the gold from the data. So that's why we call it analytics the new era acme. So when we talk about analytics, actually there are different types of analytics. So here gives you a very brief overview of analytics. So when you look at all those companies claiming to do analytics, most likely they are doing descriptive analytics. So what it's trying to do is basically scanning all the historical data, trying to see what is going on. So it's more like hindsight, trying to tell you, okay, what happened. Then based on that, you have aggregated view or some nice visualization or dashboard to see, okay, these are all the events that happened. Then on the next step is trying to do predictive analytics. So this is based on what has happened, you're trying to figure out what will happen in the future. And then this is essentially trying to give some insights to customers. Then at the same time, you also want to give some diagnostics information as well, because typically when you give some prediction, most people would ask, why do you predict like this? Why would this happen? So that's why, like, when you're trying to provide some predictive analytics, most of the time, I think you should provide some diagnostic analytics as well. Then beyond this insights information, the next step you want to do is trying to provide some foresight. Say that your customer does not like your prediction. He wants to change the outcome. Then these are the questions which basically you are trying to provide some prescriptions to customers, saying that, okay, if you want to change the outcome, these are actions you want to take. So that's essentially when analytics meet actions. So as you can see, the analytics is basically from these 4 different types of analytics, basically trying to convert data into certain value. So that is essentially what Clari tries to provide, basically from descriptive analytics to prescriptive analytics. But for Clari, we are working on one particular domain, sales. So in case you are not quite familiar with the sales process, I just give a very brief kind of introduction about this typical sales process and what are the pains with these salespeople. So a sales funnel typically works like this. Through some marketing efforts, you probably will get some leads or some prospects which are potentially interested in your product or service. Then from there, you're trying to identify which are likely to buy your product or service. Then basically you convert into one opportunity. Then once you convert into opportunity, then salespeople would just jump in, trying to contact this account and trying to negotiate about the price, set up trials. So that's what salespeople are basically trying to convert this opportunity into a customer. So in the first step, that's what basically there are many companies doing some lead scoring, giving all these prospects, trying to rank which lead actually is most likely to convert into your customer. But what we are trying to focus is sales management. So essentially, it's like once an opportunity is created, we're trying to see what kind of efforts we can do, or what kind of help we can provide to help these salespeople to convert into a customer, to convert one opportunity into a customer. So when you look at this opportunity life cycle, actually, especially in the B2B world, this life cycle is very long. And there's a saying that on average, the time to convert one opportunity into a customer takes 9 months. So this is very different from what I have been doing at Walmart Labs or at Yahoo. Basically, like for the consumer market, it's just one click, you immediately get something. Or if you go to Amazon, you just place one order like that. But for B2B world, there's a lot of building up the relationship and trying to identify what your customer really need, negotiate about what are the requirements, and then trying to finalize the price. So in all these processes, you can see here, there are a lot of things going on. But there's one critical factor, is basically time. The longer it takes, the less chance you will close this opportunity or close this deal. Because there could be different factors, like it might be the case that at the beginning there's some budget, but after some time the budget has been eliminated or has been on hold, or you identify certain champion which have been saying a lot of good things about your product, but they have moved to some other companies. Then you need to basically restart the whole process. So what we are trying to do is basically, can we somehow provide some insights to tell the salespeople to understand, okay, which opportunity they should put more attention to. So typically, like for salespeople, they manage like hundreds of opportunities. Then you want to keep track of each one by yourself. You want to have certain way, okay, prioritize all these different tasks, prioritize all these different opportunities, and see which one you should pay more attention to, like that. Okay, so that's what Clari is trying to provide is essentially we have two components. One is from an analytics aspect is basically a data exhaust. It's a mobile app for sales rep people, so they can easily update CRM records, check status of the contact, and connect the email, LinkedIn information, and also get some related news about certain accounts. So this is essentially, because it's so easy to use, then it's essentially you're trying to engage all these sales reps to use your app. Then based on that, we're trying to collect all this related activity data into our server. So based on that, we can provide some data science insights to managers. So for sales managers, what we provide is a deal progression view. It's essentially an overview of all the opportunity has been owned by him or by his team. Then you can see what is going on, which deal has been pushed to the next quarter, like that. Then based on that, we also provide some analytics dashboard, basically like some visualization to see what is going on with all these deals. So this is essentially some descriptive analytics. Then the next thing we try to provide is a Clari score, which basically trying to assess how likely this deal can be closed as one. So this is some information the salespeople are looking for. And then from this risk analysis about these opportunities, you can aggregate them to do the forecast. So because this Clari score actually provides a very important role in all these products. So tonight, what I'm going to focus on is what are the efforts we're trying to do to compute this Clari score accurately. Okay, so here give you give you a pic of what this Clari score look like. So essentially, when you have a deal, say like for this deal, Macca's expansion, then it has 5 days to close. Then here basically we show Clari score saying that okay, Clari score is 93. So this score is basically trying to predict how likely one opportunity can be closed as one. So basically how likely you can win this opportunity. Then the score is range from 0 to 100. So if it's 0, that means the deal is lost. If it's 100, that means it's won. But if it's in between, it's basically just a probability. to estimate how likely this deal can be closed as one. Okay, then at Clari, like this product, basically we also provide the details. Basically, it's trying to provide some diagnostic information about this score. So like for example, in this example, we basically show that this opportunity is scored at 93 because the close date has been put in. So the most like, and then the forecast has changed from best case to commit. So all these factors actually give us some signal saying that, okay, this deal is moving in the right direction, is moving in the right progress. So, so basically this can tell all these sales managers why a deal is at risk, then they can take some decision or take some action about it. Okay. So in order to come up with this Clari score, what we're trying to do is trying to formulate as a machine learning problem. So what we try to do is collect all these historical deal activities, including mobile, like some mobile activities, including your email activity, like whether or not this sales rep has sent any email to the contact, and also calendar meetings. If they have a lot of meetings, that's probably a good sign. And then another important source of information is the CRM records. So right now, most are from Salesforce. Then from there, we basically get all kinds of events about this sales rep associated with these opportunities. Then we basically convert into some labeled samples. So we identify all events associated with one opportunity. Then, because we scan all the historical records, we know that, okay, in the past few years, which deal has been closed as won, which deal has been closed as lost. Then you can construct some label information, like whether it's won or lost. Then you can feed into some machine learning engine to train a model. Then you get your prediction models. Then in the prediction phase, you just apply the model then to compute the score. Okay. So, but then when we're trying to come up with this machine learning engine, there are several challenges. The first one, actually, the basic requirement is that basically any org, they want to have a customized model. So you say if we have 100, 1,000 customers, then probably you need to build like 1,000 different models, at least one model for each customer. But we want to automate the whole process. We want to make this process scalable. We don't want to say you have to do some manual configuration to figure out which fields, which event should be used. We basically want, how do we scale this up? And then another requirement is we want to do agile model update and development. Because typically in data science and predictive analysis, the model you keep trying to explore new ideas and then trying to see which one is working. Then you want to deploy the model as soon as you found it's working. So you want to automate this process as well. Then what we're trying to do, basically we look at a couple of options, trying to see, okay, how can we set up this machine learning engine? Then what we end up is basically trying to set up this predictive analytics as a microservice. The first thing we need to do is trying to decide what are the language to use for development. So for Clari, then there's some, because most of our code base is in Java. So that's kind of one concern we really have to consider. And so we look at Java, but then the issue is that Java is really bad at certain operations, especially collection operations, and also it's very error prone. And for data scientists, Java probably is kind of the least favorite language to use, and it requires a lot of effort, even just to do some simple tasks. And then we try to see okay, whether Python or R, basically these are the two most popular languages for data science, whether or not these two are working. What do we see is that, because from my past experience, like at Yahoo, at Walmart Labs, typically they separate this data science, data science from production. So essentially you use Python or R to do some prototyping and see which one is working, then trying to convert the model into production. So of course, using these two, probably because there are many existing libraries available, it's pretty convenient for data scientists to do some quick experiments. But the problem is that deploying these models is essentially trying to rewrite everything. And it's really requires a lot of efforts. So at the end, we decide, okay, we should not pursue these two. Then the remaining one we consider is basically Scala. So Scala, I think the first thing for us is that because Scala is compatible with Java, so many of these existing functions, APIs, can be called directory. So this is a kind of for us, it's kind of a very interesting case. It's not pure Scala. It's kind of mixed Java with Scala. And then also because Scala, it has many features which is really convenient to use. I guess most of people here, if you are interested in Scala, you have already heard a lot of things about the good thing, the advantage of Scala. And we are picking Scala. Another reason is that because because of Spark. Because Spark, it has a machine learning library, and it's written in Scala. So that's also kind of putting another vote into the choice. Then in order to set up the predictor analysis, we also want to separate this model improvement or deployment from product release. So what we try to do is basically we hide this predictor analysis component into a REST API so that we can change or we can build a model anytime, we can change the model anytime, which would not affect the product release. So in this way, we can, for data scientists, we can keep continuous trying to improve the model and just deploy the model directly. For other components of the product, everything just talk to this REST API. In terms of machine learning libraries, as I mentioned, like Spark has a machine learning library. It's still pretty primitive. I think it's still pretty preliminary because it only covers the very basic ones, like some k-means clustering, some simple classification, like linear regression, logistic regression, and most of these methods are implemented based on some gradient descent method.
Can I ask a quick question?
Mm-hmm.
So, I mean, you mentioned in the beginning, you mentioned you guys are trying to machine learn salesman's behavior. Yeah. I think I slightly have different opinion, but probably I'm not sure it's right or not. I think if I want to sell my service to your company, I would really care about. I would like directly sell to your CEO instead of to you or your coworker. So of course there are the two sides of coin. One is salesman's activity, which is very important. You want to machine learning. But on the other side, if you look at LinkedIn, how they do that, actually LinkedIn are not selling their internal software, but they have massive social network, and they know how they can convince, give their salesperson, their field salesperson, to call or email the VIP. That's it. And the other side is you mentioned, traditional sales funnel model is slow. I totally agree with you. But if you look at a new model like Alibaba or even AWS, Amazon, AWS Enterprise Marketplace, those sales sessions are very quick. When I saw an enterprise app, I immediately click it, and if I don't like it, in 3 or 5 days, I immediately stop my subscription. So that will be very, very fast.
Okay, thanks for the point. So for the first one, I think if I understand correctly, he said that because we're selling product to the enterprise, we should, rather than focusing on sales reps' behavior, we should focus more on the executive or managers, right? So that's one valid point. So basically, because at the end, for enterprise, the decision makers are executives. So what we're trying to do is we're trying to convince them that there's a lot of value from Clari product. So one way to show that is that, okay, if your team, sales rep, everybody likes this product and found this valuable, then that's one way to convince this manager or director or VP to buy your product, okay? And another thing I want to emphasize that this predictive analytics is basically trying to provide insights or values to managers and executives. For example, like forecast. So essentially trying to basically provide insight for them. So that's why, like at the beginning, I mentioned about this predictive analysis mainly focused on sales managers. So this is one way, basically showing the value that we can help salespeople to close deals faster and earn more revenue. Then basically we're trying to convince this executive to buy our products. Okay. For the second question, I think there might be some new ways to basically trying to accelerate the sales process. But what we are seeing that it's a new trend, but for many, especially medium to big sized enterprise, typically this sales process, as I mentioned, it still takes a long process. And for any salespeople working on that particular market, it's still a pain trying to manage so many opportunities. So I think both are valid. So basically, it depends on what kind of market you are focused on. Okay. So any other questions? Okay. Okay, let's come back to these machine learning libraries. So there are two other choices available as well besides Spark. So one is called Weka. Actually, Weka has been existing like for a long while, and it covers almost. I guess it's probably the most comprehensive machine learning library written in Java. So, but the issue is that Weka is mostly on a single machine. Of course, there are some efforts trying to basically pour this Weka library into Hadoop MapReduce, but still, I think right now is still a lot of pain trying to convert things into some parallel or distributed environment. Another one, actually, machine learning library, probably, if you're working in Hadoop MapReduce, you probably heard about this, Mahout. So Mahout, I think at the beginning, they are basically just solely focused on machine learning under the Hadoop MapReduce environment. And there are a lot of activities going on, even though I know that certain algorithm were not implemented correctly. So it really depends on what kind of algorithm you are using. And the documentation can be the documentation is also a mess, I have to say. So like in the past, I have been trying to use Mahout, but I never succeed. I just say it takes too much time to understand what is going on there. So that's why right now Spark comes up. And actually, one interesting thing is that Mahout, they're trying to change all their developer efforts to shift from Hadoop MapReduce into Spark platform. So that's also a sign. So considering that, that's why we decided to choose Spark. So Spark, there are several advantages. One advantage is it has some machine learning library. And the second advantage is because it's written in Scala, many of these Scala's collection operations you can just apply directly into the Spark environment. And the third thing I really like, actually, is that Spark can easily run in a local mode or in a one node cluster. Because for many of these data science efforts, you don't need to run your algorithm, say like 1 petabyte of data and waiting for like say 1 hour or 2 hours to get the result. Most time, you just get reasonable sized data set and run some quick experiment to see what is going on. And then if you write your code in Spark, then you can run all these quick experiments probably in your local mode, like on a laptop. Then once you need to deploy into the production, you just change your Spark configuration to be a cluster rather than just your local laptop. So this basically like you don't need to worry about what this Spark cluster is. You just focus on trying to make sure your code is working in Spark environment. So I really like this feature. So that's why at the end we use a lot of Spark trying to develop these predictive analytics features. Okay, so come back to predictive analytics. Let's look at what we try to do. So here, next we are trying to work through a couple efforts we have been done in order to address this predictive analytics problem in sales domain. So for our data, the first question is what kind of data are we handling? So data we had is actually mostly in CRM history records. So basically, all these records are in the form of events. So basically, each event, you have some field, basically saying that which field has been changed. And then, so this field could be stage, could be the salespeople's forecast, close date, deal size, or is there any competitor like that? And then the value is very heterogeneous. It could be Boolean value, numeric value, categorical value, or just some free-form text. Like sometimes people just take some notes. So all kinds of values. and then you have some update time and update owner. So given that, what we see is actually all the data is, as probably you're working on any domain, data is never perfect. You always find some issue with data. So the first thing we found that is sequential events, because we see that the event type actually are highly heterogeneous. As I mentioned, there are category values, there are numeric values, there are free-form text. So you have to do a lot of transformation trying to make sure, in order to feed the data into your machine learning engine, you have to do a lot of normalization to make sure you derive the right type of value from the raw data. And another thing we noticed that events can be highly correlated, because in all the CRM records, they could define a formula, basically say this field change to this value, plus this field change to this value, then I update my forecast to something like that. So sometimes there could be just almost like identical updates. It's just in terms of different names. So this actually can be when we tried some type of linear regression to this actually gives a lot of trouble when trying to pop up what are the right factors to show to the user. And another thing is about the data quality, because most of these existing CRM records require human beings to do the update, requires manual entry. You know that everybody is lazy. Why do I want to type all this information? So then it's no wonder that we see actually almost across all the organizations, there are significant percentage of opportunities which is just created and closed within 1 day. So it's just created and closed. So as you can see that in order to derive some useful information from the data, you actually need to do some data cleaning as well. And one other thing we also thought about is because most people probably are they are reluctant to do the update. So if somehow a field is missing, should we consider it's really not happening or it's just missing? How do we differentiate that? How do we consider this factor into our models? So all these pose some challenges. So when we're trying to address this problem, the first model we thought about is trying to formulate as a Markov chain. So in Markov chain, basically you're trying to assume that your current event, is only depending on the most recent event. So suppose you have an event sequence like this from U1 to UM, you can factorize like this conditional probability. The probability of U1 of the first event happening times the probability of the second event given the first event. So basically, in this way, you can just compute the probability of an event sequence. And then in order to compute these transition probabilities, it's actually pretty straightforward. You just scan your data, do the counting, and compute the conditional probability. So it's just one scan of the data, then you get the model. So here just shows one example of the transition probabilities. Say for any opportunities created, then with 20% chance it will move to a stage saying customize. Then when they are at stage customize, with 28%, they will move directly to 1, basically winning the deal. With 30%, move to lost deals. So in order to predict, say for active deal, how likely they're going to be closed or closed as 1, essentially we just consider this doing a random walk. Start from your current value, do random walk to see whether or not you reach the 1 or lost. And what's the probability you reach one of the nodes. So what we're trying to do is essentially, there's another thing we need to consider that events happening at the same time. So because we noticed that many reps probably update 4 or 5 different fields at the same time, then you have to consider, which event, one way to consider, should this event happen before the other one, or should it just consider simultaneously? So at the end, we just model this event sequence as a current flow. To say you have the first event, then at timestamp T2, you basically 3 events happening. Then at timestamp 3, you have 2 events happening. And at the end, you close this deal as 1, and at the same time, there's some other events happening. So you can see that you say there's some current flow from this beginning, just try and flow forwards and see whether or not you can reach this this sync node 1. So in order to compute the probability, basically you just consider won or lost as a sync nodes, and from your current status, you do some random walk. You can do and then trying to see how likely you are going to reach this node. So say like with 18 with like say you do random walk 1,000 times, 800 times you reach the node 1, 200 times you reach the node lost, then basically you know that you have 80% chance of winning the deal.
Question.
Mm-hmm.
So how realistic is it to assume that the Markov model works as a mathematical model for a sales process? Because in Markov models, you have the constraint that the current state depends only on the previous state.
Mm-hmm.
It doesn't depend on what happened before. But is that realistic for this type of problems?
That's a very good point. That's actually what I'm going to talk next. Because this Markov chain model is very simple because it's memoryless. It only depends on your current status. But when you think about this event sequence, actually the history matters. Typically, like say, if you have some closed state push out, that tends to be a negative sign. If you have some reverse change, like from later stage to early stage, that's also a negative sign. So we have to consider the history information, not just the current value. So what we try to do is we try to bring a posterior probability. So what we're trying to compute the probability is based on the Bayes theory. So we're trying to see, okay, you will have some prior probability of winning or lost. Then you also have this from the historical data. You try to compute the probability of seeing this sequence, of seeing this sequence given the outcome is 1. So essentially, you just separate one deals, those opportunities which close as 1 from those which close as lost, and then trying to build a different model for each. Then you can apply this formula to see, okay, what's the posterior probability for this deal to be closed as 1. So in this way, you are essentially just basically computing the probability, like given suppose the deal outcome is 1, how likely you are going to see such an event sequence. So this will basically tells you how likely this can be closed as 1. Okay, and then there's still some problems with this Markov model. One thing we noted that actually the same field dependency is pretty high. Basically, like say, if you move the stage from different stage, you want to model the same field dependency. So then you can easily change this Markov chain model, say, into a model each field as a separate Markov chain. Then you end up with K Markov chain. But on the other hand, you lose the cross-field dependency. So like say, if you change your stage, but somehow your forecast tends to be changed as well, then you didn't capture this cross-field dependency. So that's why we have to move on to a different model. It's called Markov process with states. And so here to give you one toy example of this Markov process with states. So say you have, so here, this S1 to ST basically showing the state, and the Y showing the observations. So the Y observations is just depending on the state. Then you can factorize event sequence like this, basically as the transition probability between states and the conditional probability of observation given the state. So then, as you can see, even though the formula looks a little bit like complicated, but actually in training process, it essentially just requires computing this transition probability and this conditional probability. So if you are familiar with this speech recognition or natural language processing, you probably know that one classical example of this Markov process with states is basically the hidden Markov model. So in a hidden Markov model, basically, the states are hidden. You're trying to infer what are the hidden states. But that model has been used very successfully in all these like sequence data, like speech recognition, trying to like understand the language, natural languages. But for us, I think we have an advantage that we're trying to switch to a different one called the visible Markov model. So it's essentially we basically assume that the states are visible. What we use, basically we use opportunity stage as a state. So in that way, we don't require extensive like extensive EM algorithm trying to figure out what the hidden state as in hidden Markov model. Then we use opportunity stage as state. Then all the other fields is just considered as observations. It solely depends on this stage. So this model actually is very efficient because training is basically just counting and computing the conditional probability, as mentioned here. Because you know that what are the state, what are the observations, you essentially just count and compute these probabilities. Okay, so far so good. But when you're trying to comprehend, like overcome this, figure out what are the risks associated with one opportunity, there are many other factors you can consider as well. So you can consider the time staying at a particular status, the past wins. If somehow a sales rep tends to win in the past, then he's more likely to win for this one particular opportunity as well. If this account is a kind of an easy winner, then if you are trying to redo the business with them, you're very likely to win as well. And then the number of CRM updates, the recency updates, and also there's some periodical patterns, like say at the end of the quarter, people tend to close the deals and update the CRM records. At the end of the year, that's also like a lot of updates going on. And also, we wish to bring the email and the calendar activities and also the content information into the model as well. So there's so many different factors to consider. We cannot hard code this one by one. We definitely need a more scalable approach. So that's why we switched to one method, basically trying to do this automatic feature learning. So this is the overall architecture. So our data is stored in some NoSQL database. Then there's some data loader, basically trying to load the data. Once we load all this opportunity data, event information, then the first thing we try to do is trying to generate the label information. So as you will see, actually this label information can be customized and depending on your tasks. Then combining this label information and this data, you can define all kinds of features. Let's say in this feature generator, you just define all kinds of features. And then once the feature generated, you basically send to an indexer, essentially trying to convert all these features into some index numbers. Because if you apply any kind of like machine learning library, they assume that your data is well formatted. And basically then, but in practice, basically you have to find raw data and then go through all these transformations, then become your training data. So once you have the training data, then you can just feed it into Spark machine learning library, build a model, and then save the model into the NoSQL library. So that's basically the overall architecture. What I'm going to talk about more actually is not about the model anymore, but about this feature generation process, because that's the most time-consuming part for almost all data science efforts. Okay. So,
how do you save the model in the database?
I'm sorry?
How do you save the model in the database?
Oh, we combine this feature index information and then do some transformation to save as a JSON object in the database.
Oh, so you just serialize it into JSON object?
Yes. Yeah.
So you're not using any Spark?
Yeah, for prediction, we are not using Spark. Because
for the models, Spark doesn't have any capability to save the model data, right?
No, so that's why later I will talk about it. We need to do some transformation about the model, do some conversions. So, okay. Yeah.
What kind of NoSQL you're using? Open source NoSQL?
We use Mongo Labs Cassandra. So that's yeah. Any other questions? Okay. So feature engineering. I know that many data scientists like to talk about models, but I want to switch, ask people to emphasize more, pay more attention to feature engineering. Because like most time, if you look at all these machine learning libraries, there are well-developed models there. You don't need much effort to like rewrite the model, rewrite some algorithm, unless it's some specific task. So basically here, thanks to Spark, there's some machine learning library. There are kind of some standard machine learning model there, so we don't need to worry about that. But in practice, the features are really a time-consuming effort. Most time, you're probably trying to come up with new features, reasonable features, and trying to determine whether the features are relevant to the model. So that's why we have this feature generator. It's essentially defined as an abstract class. So essentially, once you feed the data into this class, you basically yield a collection of instance ID and the feature and the value. So basically, we're trying to convert all the feature value into some numerical value so that it's easy to do the processing in Spark. So whenever you have some new feature, you basically just define whatever transformation. You basically by extending this abstract class, and then each feature generator is basically mapped to a RDD in Spark. Because RDD is a lazy evaluation, so essentially you can apply a sequence of transformation there. So it's pretty convenient. And then because most time your feature generator is defined just over the same collection or different collection of data set. So this can be highly parallelizable. So you basically apply all kinds of feature generators to the same data set by using the capability of Spark by keeping the data in memory. So that's a really nice one. Then the next one is you want to do some feature selection.
Can you explain again that first part, yield collection?
Okay, so essentially you're trying to get the instance ID because you want to group by the instance ID to get all the features belong to one instance. Okay, then the feature, it could be different. You could define different types. So then it could be like a duration at a certain stage, or send out emails, something like that.
What's an instance?
Instance is basically like one data instance, basically one record. Yeah.
Opportunity?
Yeah, it's one opportunity. Yeah, because you want to basically it makes this triplet like this. Then you are allowed to do all kinds of aggregations like group by instance ID, identify all the features. Yeah.
How do you make your system scalable, both from algorithmic software architecture as well as hardware architecture point of view? 3 layers.
Okay.
Algorithm level, software architecture level, as well as the hardware infrastructure level.
Okay. So to make it scalable, I think for algorithm level, I think that's what data scientists do. You have to pick the right algorithm. You don't want to do some exhaustive search or whatever. I think that's like for most data scientists, I think they are able to tell which, at least what are the time complexity to implement, to basically to run the algorithm. And then the next thing is basically trying to keep the software scalable. That's why we're basically trying to have this architecture, basically have some very generate class, like here for all these different components, like feature indexer, actually it can be standardized. And then label generator and feature generator, you can basically just define abstract class, then you can just extend this class. So in this way, you can easily just focus on, okay, what are the features you want to add? What are the labels you want to train or to predict? So in this way, you don't need to worry about the other component once you set this up. As for the hardware scalability, I think that's one thing I like about Spark. Is basically you keep Spark configuration separately from all the whole process, so that you can run Spark basically sometimes you just do debugging. You can run on a laptop, but then if your data set is really huge, you can just change the configuration to be a Spark cluster. So that's basically we're trying to separate these different components so that you can, like I say, you have very large data set. You want to convert it into a cluster, then you can easily do that. Yeah.
So how many instances or records at maximum right now your system can handle?
So right now, it really depends on the organization. Like say, for large enterprise, they might have billions of events, but for medium size, they probably have just millions of events. So it really, actually, using Spark is not necessary for just model training because there are many tasks you can parallelize. As I said, for feature generation and also for like parameter tuning, you want to try different models, and also all these can be parallelized.
Are your the feature space, is it hierarchical or is it flat?
So far it's kind of flat. We didn't consider the hierarchical way.
So I understand that there's kind of an iterative process going on, right?
Yeah.
So the iteration, just to make sure, the iteration is that when you kind of modify feature generator class and then run the whole thing, and then so human or data scientists modify these classes, and then you run the whole iteration again to see if that's the good result, right?
Yeah. So basically, actually, saving the model into the database, you have to some criteria.
And then this iteration is done for all customers or for a particular customer? So do we have customized like feature classes per customer?
I would say most time is you define a family of features.
Can you repeat the question because people are not able to hear the question?
Oh, okay. So I just want to repeat the question here. I think the question is like, in this, when we add the features in this iterative process, whether or not we are applying to one particular customer or just all customers. And so, okay, so in this case, actually what we try to do is trying to define a family of feature generators. Say like certain fields is this value, or like duration at this duration of certain field at this duration at a certain stage, or like an email sent out at this certain stage. So you basically can apply the similar feature generators to almost all like different organizations. We try to avoid like a specific configuration for one particular customer, because that way it won't be scalable. Go ahead.
Normalize the values so that you can use them to probability configuration. The feature, business ID feature and the value, you normalize the values.
Oh, so in the feature generator right now, we basically consider there are some other transformations, say like you do normalization, you do some transformation or scaled, we all define into the feature generator, because you can define a sequence of operations into the same RDD. So in that way, you don't basically it's.
The thing is, how do you partition across different industries have different kind of feature sets. The feature characteristics vary from one industry to another. Some people have long cycle times in terms of decision making.
Yeah.
So you people have different sets of. You have something like feature models by industry.
Okay, I think the question is like, because different customers have very different set of features or different views. How can we come up with reasonable features? If I understand, is that the question?
Well, I think what I'm hearing is that
when you said that you come up with the same kind of you don't build feature by customer.
Yeah.
Do you kind of bracket the customers by the industry or something like that?
So far we haven't do that, because when you look at all these factors, it's essentially quite generic. It's quite generic. Basically, time staying at one particular status. So basically, you can look at all the fields and trying to see how long, typically how long this opportunity stay at that particular field value. And then this one is basically straightforward. And the recency updates, this one actually requires some quarter information, because different organizations define quarter differently. So you have to do some specification about that. Email and calendar activities, then we're trying to associate with the stage of the opportunities. So in that way, you can also basically standardize across different organizations.
I think one challenge is you don't have any sort of golden results to compare against. And what is your right now? What is your current goal function?
Yeah. So later I will talk about how do we evaluate the models. So yeah. Okay. Let's just move forward. So that's for the feature generation, actually. Then the next one is we want to do is feature selection. Basically, once you generate all these relevant features, and for prediction phase, you want to do some selection, because certain features actually takes a long time to generate. So you really want to identify those relevant features. So what we do is that we basically, when we train the model, we basically typically prefer some sparse models, like with L1 regularization. So you just identify which features are relevant. Then for training, in the training phase, you try all possible features. But in prediction, you only generate those features as necessary, so that it will save time for prediction. Then this, so so basically in this case, then when we serialize the Spark models into the database, you have to do some transformation about it, because keeping the raw model basically does not satisfy our requirement. So basically, we identify which features are relevant, and then combine with those feature generators and save into the model. So in the prediction phase, you just pick out those relevant features to use. Okay, so here, so that's basically a general process for feature generation and selection. Then the next one is basically we want to do some model comparison to figure out which model or which feature sets are more reasonable to use, right? So then this is how we do the evaluation. So basically we say, like right now, today is April 13th, then we try to go back sometime, say go 1 month back. And at that point, we use whatever data available until this point to train the model. Then we're trying to predict the outcome for all those active deals at that particular time. Then we essentially wait for 1 month to see, okay, what are the actual outcome compared with our predictions. So essentially, you basically go back 1 month and trying to predict the current result, and trying to see whether or not your prediction match with the current result. So in this way, we are able to evaluate different models or different feature sets. And so in order to compare the different models, because this is essentially a classification problem, then you have different metrics like accuracy, F measure, but this is highly depending on one threshold. What matters more, because we are trying to predict the probability. So what matters more is like a relative ranking of these opportunities. So that's why we use that's why like these metrics are not usable for model comparison. What do we want to use? Use some ROC curve or AUC or some probabilistic metric like perplexity. So I won't go into details, but this, as you can see, this is just one example showing that, okay, based on the model, the AUC is like 0.88. So then you can, based on this number, to do model selection. So. And here just shows one example of one customer, like basically what are the score distribution look like. As you can see, it range from 0 to 100 for all these open deals. But if you notice that actually there are essentially 2 spikes here when we try to use like all these existing like machine learning libraries like SVM or logistic regression, you see there's 2 spikes there. The problem with this is that many classifiers are well optimized for binary classification, say positive, separate positive from negative. They are not tuned for probability estimation. So that's why you are seeing such a spike here. So basically one towards the lower end, the other one towards the higher end. So that's why it requires us to add a calibration process. So essentially trying to calibrate the raw prediction score into a probability. So what we rely on is trying to use this isotonic regression. It's essentially like this. Here you're trying to minimize here. So basically the problem formula like this. You're trying to keep the order, the ranking order of all these opportunities based on the raw score. But you want to minimize the probability from the label. So the label can be 0 or 1 depending on your outcome. So if the outcome is 1, then your label is 1. If the outcome is 0, if the outcome is like lost, then this label is just 0. So essentially, you keep the relative order of all these opportunities, but you want to figure out what's the true probability, which are closest to the true label, true outcome. So that's essentially the basic idea. So you can use some isotonic regression to do that. And you can even enforce further smoothing, basically trying to consider like the state. So at this particular stage, the average one probability, say, is 0.5. Then you want to change the label to consider both the outcome and the average probability. Say like if for one deals at this particular stage, you map to 0.75, but for lost deals, you map to 0.25. So by using this calibration, actually it helps smooth the distribution a lot. As you see right now, the distribution is concentrated more toward this uncertain area, close to 50. And if you look at the score distributions with respect stages, so here we have 9 stages, and basically showing the progress, basically like from the beginning to the end. As you can see, the score is, as you see, the range is kind of getting higher and higher, and here at the end, the score actually is pretty like from 90 to 80, so sometimes like that. So in this sense, actually once we add this calibration, the customer are pretty happy about the score because it reflects the stage progress.
What is a stage in this case?
Like in sales CRM records, okay, the question is, what are the stages? So typically in CRM records, each organization, once they set up their CRM database, they define certain stages. So if they do not define certain stage, probably like Salesforce will just give you some default stages. Yeah.
How many labels do you have?
The question is, how many labels do we have? So right now, because we are only consider the outcome as either won or lost, so it's essentially a binary classification problem.
So what is the intuition behind your theoretical model? It looks like quite active, But anyway, and the other question is, do you have any sort of rule to split the data into training data and test data, or you don't use any sort of rule?
Okay. The first question is, I think the first question is, what are the intuition behind the model? So because right now we are kind of doing a feature generation, generate all kinds of features, and then just let machine learning to decide which features are more important. I think that's
me, the goal is like sell faster, sell more.
Yeah.
And sell in more expensive way. That's my intuition, right?
Mm-hmm.
If I'm a salesman.
Mm-hmm. So I think, as I emphasized at the beginning, the motivation is that when a sales rep manages like hundreds of opportunities, you want to know which opportunity is at risk. So this Clari score is basically just giving one number to tell you, okay, you can sort all these deals based on this score and see which deals have a low score, right? Then that you know that, okay, should you pay more attention to do that, or should you follow up with your contact to do something? So in this way, you don't need to basically check record one by one, like say, what's the stage, what's my last update with this opportunity, when did my contact send me the message? So this is more like a summarized view of all the opportunity status. You can just rank all these opportunities to pay more attention to. And the second question is, is there any rule for us to set up the training and test? So actually right now, the training process is basically like this. As we just choose one time point, and then we go back for up to 2 years, collect all the possible historical events and activities to train the model. And then for model, if you just want to train the model, basically you just like say from today you go back for up to 2 years to train the model. So essentially we don't have a specific rule because we want to keep the model just up to date.
So you predict both win and loss and also the score, right?
Yes.
And if so, how granular is the score?
The question is like how granular the score is. So as I mentioned, right now we're trying to figure out the probability of closing as 1. The granularity is essentially from, you can say, because it's actually a probability score. But when we show to the customer, we just show like say from 0 to 100. So that's okay. Yeah.
Question. Why did you choose to predict? Why didn't you just pick, for example, historical 2 years minus 1 month, and predict relative to the data which already happened, right? I know it could cheat or something, but I assume you don't want to cheat the system by
Oh,
So you don't have to wait a month until your prediction is complete. You just do the prediction on the back. That will be fine.
So I get, if I understand correctly, you are trying to see why we are waiting for 1 month to get the outcome?
Why don't you predict for the past month, for example?
Okay, so that's essentially what we did. Basically, like say, this is today, we go back for 1 month, then collect all the information before that 1 month ago to train the model, then trying to predict at this particular time. And then we basically check the outcome today with our prediction. So in that way, we don't need to wait. So it's essentially you are taking a time machine, just travel back 1 month earlier and build a model there, then trying to do the prediction compare with today's result. So.
What is the,
Go ahead.
for example, assist of the curve?
It's a false positive rate.
Do you know any sort of approach Salesforce, Oracle, or those bigger brothers they are working on this sales prediction?
I don't have a good idea about that because they might have something working on data science, but I don't have a particular idea.
Do you run the principal component analysis on your on your matrix to identify independent features and most important features?
Okay. The question is whether or not we conduct any principal component analysis to identify important features and relevant features. So the reason, actually, we thought about that, but we didn't try that. The reason is that typically this PCA or SVD-like approach, you're trying to identify a latent dimensionality, a latent feature, which is possibly a linear combination of different features. But what we want to do, as I showed at the beginning, we're showing a score. We want to show the relevant factors. If we just compute the latent factor, then it's difficult to explain to customers why we are scoring like that. So that's why at the end we didn't push into that direction.
Did you try to use neural network just with your features? How many features actually? How long is your vector of features?
We haven't tried the neural networks yet. So, but I know that right now deep learning is kind of very hot. That possibly can be used here as well, but we haven't paid more attention to that.
What is the order of your feature vector? How many? Hundreds?
So the question is about the dimensionality of features. So it really depends on the feature generators. So you can keep adding features all the time, or you can just do certain transformation. For example, there are many numerical attributes such as deal size, but actually you don't want to use the deal size directly, but you want to discretize, like say small deal, medium size, or large size. So in that way, you're converting into categorical attributes. Then one attribute actually converted into three. You can convert these attributes into 3 binary attributes if you want to do classification. So the number of features could range from hundreds to thousands. So.
Okay.
So the fact that you actually look at 2-year historical records, is that a problem for sales that might be seasonal? I would assume that something sells more often in summer than in winter, and perhaps looking at 2 years is a problem for that, or not?
Okay, so his question is about, because typical sales process have this seasonal pattern. So if we just go back for 2 years for training, whether this would cause any issue. So that's a very reasonable and valid point. And so we are trying to tackle this seasonal pattern, but so far we haven't put much effort. We're thinking about trying to assign like a larger instance weight to recent records, but there's still some work going on. So.
But you can include it as a feature, months of the year or something.
Yes, that's another way to address that. Yeah.
How often do you retrain the model?
So typically right now we just retrain the model a couple of days because we just want to keep the model up to date. Yeah.
How reusable are the categories between customers? I assume you have some kind of global reusable categories, right? And I assume some of them would be very particular for some customers. What would be the percentage within the global general and the one specific?
I'm not quite sure get your correct.
I assume that some of the categories you discover, you extract, right? Some of the features you extract are general and some will be specific for some customers. Are you going for this specific or general, or you just try to use the general categories for everybody?
Oh, so the question is whether we are applying some global features or general features across different organizations, or just specific features for each organization. So the one thing probably I didn't mention much is that we are building a model for each customer. So so essentially, you can claim that the features actually identified relevant to the outcome is just specific for that organization. So, but the feature generation process is more general across different organizations. Okay.
How do you handle your model? Do you keep all of your model, keep on refining your model, or you only keep like a set of model, or your model library keep on growing? That's one thing. The other side question is, do you have any sort of integration with the marketing, existing marketing solution, or you wanna work on your own?
Okay, so the first question is, how do we keep our models? As you see here,
because you haven't told you, I asked the question in the beginning is what is a golden model? Because it's harder to define or specify a golden model. It's really hard. You know? What is your golden model? Is it the best sales results or whatever? Because that's hard. So how do you compare against the golden model? Golden model does not exist at all.
Okay. I think the first question is still trying to figure out what are the best model. Okay. And so that's actually
close to optimal model.
That's actually a pretty tough question, because in many business applications, you don't have a good sense of what should be the things to optimize. So here, for us, we know that we want to reduce the sales cycle, and trying to improve the close rate for salespeople, but it cannot be turned directly into your machine learning model. That's why right now we are essentially using a proxy metric, basically using this somehow like a accuracy, like a predicting outcome, to do this model comparison. This is not perfect, but that's you have to live with.
It's hard to convince your buyers that I'm using a tool and I'm paying your money and I get a better results.
So in order to convince buyers, actually, once they run some trial study, we basically show that after their salespeople using our product, their close rate, what's the close rate before and after, what's the average lifetime to close a deal before and after. Because for most sales executives, they don't care about this number. This is more for data scientists trying to figure out what the model to use. For them, it's like just showing the value that's most important. Okay. In addressing the second question is whether or not we are interested in extending to marketing. That's I would leave into our CTO. That's probably we will consider that sometime in the future. Okay. So there's one last piece I want to talk about of the advantage of our current architecture is trying to do segmentation, because right now we are building one model for each organization, but typically for this medium to large size enterprise, they might have different sales teams. Different sales teams might show in different patterns. So that actually requires us to build you want to build, for this region, they probably sales faster, but for different regions, it takes much longer time to sell. So essentially, this requires us to segment all this opportunity into different types, and then build a model for each segment. So this is essentially you are building like under one organization. You're trying to segment all these opportunities into different segments. Then you build a model for each segment. So what we do actually is rather than providing one model, we are trying to provide a mixture of models.
Can you not treat each segment as a feature into your model itself?
The first thing we need to do is figure out the segment, because you don't know which should be the right segment. There might be different sales teams, so you can put one way is that you can put a sales team as an indicator as a feature. That's one way, and so actually I'm going to talk about shortly.
So each segment would include a set of companies with some common features. Is that?
It could be so.
Okay. So you just try to make your models more precise by doing that.
Yes. So you can think about this like, if you look at the whole organization as one piece, you just build one model for it. Then you can zoom in at a certain cluster or certain segment and try to build a more precise model for that particular segment. And you can zoom in to the extreme case, it's just one opportunity, it's just one segment. So you have to figure out a good balance between what should the segment size. Because if you zoom into just a few data points, your model won't be able to generalize. And if you just take all the opportunities as one piece, then your model basically is kind of a limited capability to model what is going on. Okay, so what we try to do is do some adaptive segmentation. So there are two approaches. I just talk about this briefly as we are running short of time. So one way is you're trying to do some clustering. So if you know clustering, then probably k-means clustering, that's the most standard one. So you can modify k-means standard clustering, and basically you're trying to change the distance metric to be the model fit. Basically, like say, each segment you build a model, then for each data instance, you're trying to apply to all the models and figure out which segment he belongs to. So in this process, you can kind of doing automatic segmentation and model building. But this is very time consuming because it's an iterative process. So that's why we resort to a different one. It's doing some supervised learning for segmentation. So you try to come up with some more like meta features to figure out the segment. Then you can just apply some decision tree, classify to figure out how to separate these opportunities into different regions, into different segments. So you can essentially apply the same architecture here to do the same to the segmentation. But here the label is still the label. Basically, there are two iterations. The first iteration is like use your outcome as a label, and use some meta features to construct a decision tree. Then you apply the decision tree to generate a new label. No, I'm sorry. Basically, then you apply your decision tree to separate all this data into different segments. Then for each segment, you retrain the model. So basically, you don't require iterative process, just two iterations. Okay, so that's pretty much for all the efforts, some kind of efforts we have done in predictive analytics. So we basically talk about predictive analytics for sales. It has a huge potential, and at the same time, there's a lot of challenges with the data. So we talk about market models. We talk about the classification. How do we scale up this feature engineering? How do we do the calibration, and then finally do the segmentation to build a model? And right now in production, actually, we can enable this predictive analytics like model training and prediction just one click. It's just one feature flag. You enable that, then it will start the whole process building the model and figure out what are the relevant features for this particular organization. And they typically complete within just a couple hours. And we also deliver some insight reports, basically trying to generate some, like, say, typically how long does it take to close one deal, like some metrics which people like as well. What are the average data science score for your team, like that. And here I just want to share some lessons I learned through the whole process and my past experience in data science as well. There's one thing I want to raise up is when people talk about scalable machine learning, some people, I guess most people probably trying to emphasize efficient training. Some people probably care more about prediction time. But actually there's one important piece which is missing is development time. If you consider data scientists like developers, engineers, if you requires a lot of time to just come up with one model, then that's not scalable. You have to have some scalable way in order to develop models fast. So I think for machine learning or data science, we should pay more attention to this. And also from our experience, feature engineering is very important because if you apply these standard classifiers, SVM, logistic regression, linear regression, yeah, there might be some difference, but if your features are similar, are the same, they won't show much difference. But if you're adding new features, that could make a big change. And the last one is you should pick the right tool and framework to build your product. As I think that's why I really appreciate Scala and Spark here, because it really has a lot of convenient features which enable us to do this fast deployment and prototyping at the same time. So.
Did you find Scala with Spark to be better than Python with Spark?
Compared with, I don't have much. Okay, so the question is, Python for Spark, whether I found Scala for Spark is better or worse than Python for Spark. So I don't have much experience with Python for Spark, but my basic, here probably could be wrong, my basic assumption, because Spark, the native language in Scala, I would assume they should have better support for Scala, right? And just for machine learning libraries, most of those algorithms would be first available in Scala version. Then they would consider port into Java or Python versions.
When working with Spark, did you run into any shortcomings versus working with Hadoop?
I think, okay, comparing Hadoop with Spark, whether there's any shortcoming about Spark. So I think the first shortcoming is for many people, Scala could be a challenge, especially if they have no experience with Scala. That could be a little bit scary. Another thing is memory management actually is sometimes can be tricky. If you have a large cluster and how to keep your memory management efficient, that can be tricky as well. Because there's no free lunch. It's not like just you load the data and everything runs smoothly.
What is the maximum size of your Spark cluster so far? And are they keep on running so that you store your data in a data lake way? I'm not sure. You shut down or you stop those instances. How do you handle your Spark cluster, and what is the maximum size of your Spark cluster so far?
Okay, so the Spark cluster is running. Basically, it depends. Because right now we are mainly just using Spark cluster for training purpose. So basically, you can just launch a Spark cluster if necessary. Because in prediction phase, we didn't use Spark cluster. And so far, because we have certain number of organizations, but we don't need to process a data set like Yahoo or Google requires thousands of nodes. So right now, it really depends on how many customers.
So you use third-party data, and actually you don't do it in a data lake way. So you store the data from day one, and you never drop any data. Data keep on growing.
No, okay. So
that's why cluster has to be running. It's a commodity cluster, right? So you don't need a SAM or NAS.
Okay, that's one way to store your data. I think that's one way to do. But I don't want to comment on that. So.
Do you use
the different algorithms within MLlib as provided, or have you developed your own algorithms or enhanced them?
We actually did use some other we did implement some other algorithm, like for the Markov model, because it's kind of straightforward. So just we implement by ourselves, and you see if you check machine learning library, there's no algorithm available for model sequential data. So it depends. So go ahead.
I have a question back to your segmentation. So since you use a k-mean, I suppose you predefine a set of number of segments.
Exactly. So in segmentation, if we're using clustering, you have to define, you have to basically provide a number, say like how many segments do you want.
So you know some companies in this region, they may have segments, you have some rough idea.
Yeah, so you can depending on the company size, you can specify that. So that's just one parameter. So we didn't pay particular attention trying to like say basically you probably want to keep in a reasonable number of segments. Otherwise, you don't want to say like split the company data into 100 segments. Then you end up with 100 different models. Because there's another thing you need to consider is in prediction phase, you need to keep all the model in memory. Then if the more models you have, the more machines you are required. So you have to make a balance, like probably just a reasonable size, like 4 or 5 different segments. And then most times that should be enough.
Yeah, so pertinent to this question, did you try to experiment with canopy clustering to actually see how many clusters you could find, and then run k-means on the numbers that canopy clustering will be providing?
So the question is whether I run canopy
yes.
clustering before k-means clustering.
Right.
I know that Mahot has that, but
right.
we didn't try.
Oh, I see. Yeah. I just was wondering if you had good experience with it. On that.
So, do you serve your prediction in real time, or is it not?
The question is whether or not we serve the prediction in real time. Of course, we serve in real time.
No, what I mean is like, let's assume a model has been trained in your case. Then how long does it take to propagate to the module which does the serving? Is it within an hour, half a day?
Okay, so as I mentioned, that our architecture is basically through this REST API. So essentially, once your model is built, you can just basically just force the prediction server to update the model.
And how long does that take? Within instantly or?
Instantly.
So it could be pretty memory bound because
it's basically just load the model into memory.
Yeah, but that if there are like millions of records, it can be pretty long, right?
Because when we are doing the prediction, it's basically okay. Model updating is just instantly, because once model is built, you can immediately update the model. Prediction, it depends on how many data you have, so that's a separate. Okay.
I think it really depends on what kind of real time you. How do you integrate real time? Because real time training, real time predictions, those are all real time. And also you mentioned the API is RESTful, right?
Yeah.
I mean, serious real time prediction should be streaming data. Data keep on coming. So that's streaming API, not the RESTful API anymore.
Yes, so just to clarify, right, the model building, training and building the model is done offline.
Right. We knew that. And the question was how soon does that model propagate to the portion, the module?
As soon as the model is built, it replaces the old one.
How long does it take? So
it replaces the old one.
So
it's always the current model.
I think you brought up a good point. So the ultimate in real time is like users hitting the website, new activation happened or new something happened, and that's immediately showing up in your prediction engine. That's the ultimate in.
Yeah, we don't update the model as every new data point.
Every microsecond you do not do that.
No, because it's when you take a look at the long-term big picture, you're looking at 2 years worth of data. So in that context, what does it mean to have for the last 15 minutes?
It makes a lot of difference. I think it depends on the domain.
Yeah, it really depends on the domain.
Absolutely makes sense.
Like for example, at Yahoo, when you were working on this front page optimization, you want to keep updating the model continuously, but it really depends on the domain. In the B2B, like a
B2B.
So it typically you won't see like tons of activities within within few minutes. You really have to make a decision depending on the application. You don't want like I build a real-time trainer, but then you find out like it's just a waste of time to do that for your application. Then it's not worthwhile, right?
So do I understand correctly that actually every new data point or training set would come from manual update coming from a customer? He has actually to make this entry for you to have this additional entry to add it to your training set, right?
Okay, so the question is whether or not it requires manual entry to add a new data into the training data.
I'm a part of your customer. From his experience, he has to get this data, enter it into something from where you take it, and is it the process?
So it can be separated. So for features, like if you have some features derived from the CRM records, which right now Salesforce is a dominant one, which basically most of the time it requires human beings to manually update or change the value or do the update. So that's why Clari trying to develop a mobile app to accelerate this process. Basically, just to make the update so easy. If you have tried Salesforce, you know what I'm talking about. So it's probably take you just 10 minutes, just do one simple. You still cannot figure out where to locate the field to the update. So that's why we think that this mobile app is really powerful. We keep all these sales reps engaged, keep improve the data hygiene, and so that we can build more accurate model. But on the other hand, like some other activities, like email, calendar activities, that's kind of separate. It's like when they set up this event invitation with account, then we immediately get the data. It's more like automatic log information.
So what was the RAM that you had in Predictive servers both for training as well as for the prediction Spark nodes? Did you cache? Did you map the entire data into memory?
So the question is whether or not we keep the data in memory.
So basically, what's the RAM?
How much memory
that you have in Predictive server?
I think right now for each node we have like 8 gig. And it really depends on this size. So
for 1 million entries.
For 1 million entries, you can easily load them.
8 gig was good enough.
Yeah.
Actually, a related question: how big is the largest data set that you process through this model?
We are processing billions of events. That's what I can tell. I don't want to be too specific.
So if you have the weights that are in the model, you could use those to figure out what actions might be taken to improve the score. So does your application give those suggestions?
Okay, so the suggestion is that if we already learned the weight associated with different features, then we can leverage that to make suggestions about actions to take to improve the score. That's a very fair point. The issue, we noted that there are many features are not actionable. So, like say, there's one feature, like say you send a price quote to your account. If they didn't send, we cannot suggest them to send, right? So, that's why, like, in order to provide some prescriptive analytics, we need to figure out what other actions can be taken. Then we decide which action to suggest. So that's kind of, we have to take care of it separately. Okay, any more questions? Okay, thanks for your attendance.